Hello, everybody. Thank you for attending another one of our monthly webinars. This month here we have a very popular gentleman back again, Mr. John Robbins from Wintellect. Before I hand over to John and you get to listen to him for about 90 minutes, I'm just going to run through some of the usual housekeeping chores that we have to do. First on, thanks to our sponsors, Ortrip, Telerik, Inner Workings, Sync Fusion, Pluralsight, and Wintellect Now. We want to thank all of you guys for your continued support. Without your support, we just wouldn't be able to do what we do. About info, if you're going to be having a need to get hold of us, email us at info@lidnug.org. You can always catch us on the social. That's twitter.com/lidnug and facebook.com/lidnug. And we will have plenty of guys able to answer your questions there. Our archives can be found on our YouTube channel. That's youtube.com/lidnug. Before we head into some of John's details, December, we have a double up on December the 4th. We're going to have our 18th Scott Guthrie Open Q&A. This time here is a 60-minute Q&A. And I'm pretty sure, considering how many new things that's been announced just in the last 2 months, if nothing else, that we're going to have a ton of questions come Scott's way again. For those who don't know, Scott Guthrie is the Executive Vice President at Microsoft for Windows Azure. They also have Walt Witcher doing an ASP.NET MVC for web form developers, basically an intro to MVC from the web form perspective. John Robbins, he has presented for LIDNUG members on several occasions already. Rumor has it that he does know .NET quite well. He's written several technical books. He's a blogger. You can always catch some interesting topics on his blog, wintellect.com/blog/jrobbins. He does Twitter on occasion, not as much. That's John Wintellect. And also, he's a former paratrooper and Green Beret in our armed services. Quick thing, if you need to ask a question of us, use the Q&A tab. Go into Q&A, type a question, and present it. Now be aware you can only have one question live at any given time. As soon as that question has been responded to, the moderators and LIDNUG members in here will remove that question, and you can ask another one again. Geographically, we are somewhat dispersed today. Quite a lot of people in the US and in Europe. We have a few people in Australia registered, and quite a few people in India as well. So thanks to everybody for turning up, and again, John, thank you very much for coming on board again and presenting for our members.
Thank you very much, Brian and Peter. It's really great to be back, because I always get a ton of great questions from the folks around the world. I think it's pretty amazing to look at that attendee geography and see where everybody's coming from. It's just kind of thrilling to know that we're getting to talk to the whole world. And that's what I think is neat about the LIDNUG folks, because they are drawing from all over the world to make .NET developers better. So I found a lot of good presentations there, and I hope you find this one good. So I'm going to start sharing my desktop. I'm at 1280 by 800, so if you want to press F5 in the live meeting, that will maximize so you can see my entire desktop. So couple odds and ends before we get started. What we're going to talk about today is cool performance stuff, finding and fixing .NET bottlenecks, what's going on when you have .NET problems. And if you have any questions about this presentation between now and the end of time, you can always send me email, john@wintellect.com and @JohnWintellect on Twitter. You can direct message me or just shoot me a regular tweet, and I'll be happy to get back to you. And Brian's right, I really should use Twitter a little bit more. In fact, since I don't tweet a whole lot, pretty much all I tweet about is debugging and performance tuning related things. I'm not going to tweet about my breakfast, for example. I just haven't quite figured out why that's exciting. But if you want to follow for debugging and performance kind of things, you could do that. Another thing that we've got for you is if you want more of this presentation that I'm going to do here today, and you want more about Azure and debugging and Angular and 330 plus sessions, we have those available for you at Wintellect Now. Feel free to use my code JohnR-2013, and that will get you 2 weeks for free at wintellectnow.com. So you can watch this training, you can take notes on it, and you can see more 330 other classes that we've got up there. We're pretty excited about Wintellect Now, and we wanted to give the folks that show up to this presentation a shot at taking a look at what we've got up there, and we hope you find it useful. So I hope this is okay, but that's all the PowerPoint slides I have. I know you guys are really would like me to stay inside PowerPoint for the next hour and a half, but I know you hate it. But I actually am going to stay in PowerPoint for a second, because we're going to talk about memory today. And we're going to talk about the .NET memory, and there's a couple of things that I really want to cover in this presentation. And the first is I want to talk about, to make sure that everybody is up to speed on how the .NET garbage collector works. Because, you know, if you've looked at my bio, you've looked at what I do at Wintellect, I debug and performance tune other people's applications. And I'm going to tell you now, all of your performance problems are related to memory. Right? What are the top 3 things you care about as a .NET developer? It's not vacation pay and benefits. The number 1 thing you care about is memory. Right? It's all about the memory. Now, what's the second most important thing you care about? Memory. What's the third thing you care about? Memory. How about number 4? Well, guess what? That's memory too. Everything at .NET, when it comes to performance, is memory. And this is kind of a surprise to a lot of folks, because when you have a lot of folks that are writing big .NET applications, right, they're thinking, well, my I/O might be a problem. Well, yeah, it can be, right? Slow databases, busy databases can be a little bit of a problem. But for the most part, most of your problems are directly related to memory.
John,
so I want to start.
Just interrupt a second there.
Sure.
Is that slide you've got on supposed to be showing something, because it's showing blank?
Yeah, I'm sorry. I was going to start drawing some pictures on that.
No problem. I just thought I better check.
Yeah, I realized as I was talking, maybe I should let me draw a smiley face on that so everybody can see. So there's Peter looking out for you, because I was going to draw some of the garbage collector here, but I just started talking about that whole idea of memory. So we're going to start out talking about memory here, and we're going to talk about how it works and some of the ramifications of it. Then what we're going to do is that we're going to turn over and look at the Visual Studio profilers, because there's something very interesting that was announced last week, and that's the Visual Studio Community Edition. Right, that's the free edition that anybody can use. It supports plugins. And in essence, the Visual Studio Community 2013 Community Edition is Visual Studio Pro. And what does Visual Studio Pro have? Now I've expanded out the debugging and performance tuning. And these performance tools I'm going to show you here, the Performance and Diagnostic Hub, you all have access to them. Now, Visual Studio 2013 Community Edition is a license restriction, okay? And I'm not a lawyer, I'm not a Microsoft employee, but the way I understand the restriction is this. If you're working on open source projects, you have full rights to this, so you can use everything I'm going to show you. If you are working in academia and you're taking a class, you have full rights to Visual Studio Community Edition. If you are working in a business that has less than 5 employees or less and less than $1 million in revenues, you can use Visual Studio Community Edition. For the rest of you, if you're working at a big company like at Wintellect, we're not legally allowed to use Visual Studio Community Edition. But I want you to realize that it's a pretty loose license. Check with Microsoft as to where you stand, but you all have access to these performance tools I'm going to talk about today. So it's not like we're talking about Visual Studio Ultimate, which almost nobody has. We're talking about the same stuff, that we have. We're going to go through, and I want to get, my goal with this section is to get everybody up to speed on what these tools can do and how to use them, because I don't think Microsoft's done a very good job showing people how to get into the tools. But we're also going, and I'm going to use them to go look at a real-world performance problem. And finally, I'm actually going to talk about another commercial tool called the Scitech.net Memory Profiler, because I want you to see what and compare and contrast what you can do with another commercial tool to look at your .net memory. So that's what we're going to cover here: is how the garbage collector works, how to use the awesome Visual Studio tools that you guys all have access to, and we're going to talk about the Scitech.net Memory Profiler, which is a commercial tool. So let's go back to my blank slide. Sorry about that, which is kind of funny that I wasn't drawing anything. I should have. And what we're going to do is that we're going to Control P, W, there we go. PowerPoint's crazy. So the first thing I want to talk about, just to make sure everybody is on the same sheet of music, how does this garbage collector work? Because everything in .NET comes down to this garbage collector. So if you think about what a garbage collector is, the idea is that it is a system that allocates memory until you run out of memory. So in essence, they just carve off the big block, and an allocation in .NET is simply a pointer move. So there was the beginning right there where I circled, and then they move the pointer, and then you allocate again for the next size. Then you allocate, you allocate, you allocate, you allocate. And the idea with the garbage collected system is when you get to the end of memory, they say, wait a minute, we're out of memory. Let's trigger a garbage collection. And what that does is they look at all of the objects that are in memory, and they look to see if they are rooted, okay? And what that means is, does this object, is it referenced by, draw a little cloud there, let me write rooted here, and rooted, we'll call it roots, because I can only draw so well with the mouse. And a root, that is something that is on the stack, right? Local variable parameter, a static, things like that. So, it's got a reference, so it can't be garbage collected. And of course, you can have multiple roots, and you can have objects that reference other objects, right? Your HTTP context that references a page object and so on. And so what happens is you run out of memory, and then they collect. And what that does, they use an algorithm, and you can look this up you can Google this with Bing, as Scott Hanselman says. So this is what it looked like originally, and what they will do is they compact, so it's a sweep, mark, and compact algorithm, and then they compact all of these objects together, and great, now that's the next pointer right there, so then we can continue to allocate. And that's the basics of a sweep, mark, and compact garbage collector. But now, let's think about this for a minute, right? If we would implement something like this, they're not really hard. There's been a lot of research papers out there, and there's many implementations you can find on GitHub and other places. In fact, Microsoft is open sourcing their garbage collector here in a few months. So we're going to get to see how Microsoft implemented theirs, because that's pretty much the fastest garbage collector ever written is the one Microsoft did for .NET. But the problem we have here is that we're just going to allocate memory until we run out of memory. Now, how many of you have been on a machine and you've had that process that allocates memory like crazy until it exhausts the address space, right? Where you've got that one process that's using, like on a 32-bit computer, it's using all 2 gigabytes of user mode memory, and what happens, right? There's a ton of swapping, right? It's very slow. And if you're on a 64-bit machine where the address space is 8,192 gigabytes, gosh, you're going to have to allocate a whole lot of memory before a garbage collection occurs. And if you're using a ton of memory, it becomes a swapping issue, right? Because we've got to swap that memory from one of 2 places. Either it's cached in RAM or it's cached on the hard disk, and that page fault will kill you, because that's what the process is. When you can't get the memory on the CPU, they have to page fault, and then the operating system has to say, where is that piece of memory you're accessing? So people who write garbage collectors, they do not want to make all of memory part of their garbage collected system, because that would be very slow. So what they do instead is they're smart. And some of you have heard the term generations. So what happens here is the .NET garbage collector is broken up into 3 different generations. And they're called 0, 1, and 2. And the idea is this: all of your allocations initially take place in generation 0, right? Very quick, very easy to see. And the idea is that you'll allocate generation 0. That is a very small chunk of memory. I don't know what the exact numbers are on 64-bit, but I remember on 32-bit, they were, I think it starts at 256K. Right? That's not very much memory, but that's memory that can fit on the CPU, on the actual CPU memory. So you don't have to go out to RAM, you don't have to go out to the hard disk to get it. And most of your memory in .NET is very short-lived, right? It's used for the loop, or it's used for a 2-line function. So you allocate something, you use it, and then it's eligible for garbage collection. So the idea is that you can do all of your allocations here. And that way it's very quick when they have to do a garbage collection, because they don't have to swap everything in to get it. So great. Everything works. You fill up Gen 0, a garbage collection occurs. Now your objects are packed down to here, and then you just continue to allocate. So very quick, very easy. Eventually Gen 0 fills up with rooted objects. So what happens now? That's when they trigger a Gen 1 collection. And what will happen is Gen 0 is full. They will trigger a garbage collection on Gen 1, and they will put all the Gen 1 objects, pack them down, then promote all the Gen 0 objects up here. So they get promoted up. So Gen 0 becomes empty at that point. And so that's pretty cool, right? So that way everything runs faster. Now Gen 0 is empty. Great. You just go back to allocate. Well, what eventually happens, right? Gen 1 fills up, and then they have to promote to Gen 2. Now, Gen 0 is for your very short-lived objects, stuff that's only around for the life of the function, really. Gen 1, some people refer to this as to medium term, like what you return from a function. But, it's stuff that's held on to a little bit longer than Gen 0. But Gen 2 is the important one. That's the one where you're holding on to it forever, right? Because Gen 2 expands to all of your memory. So when you have a memory problem in .NET, you're looking at Gen 2 problems, right? That's why you always pay attention to Gen 2, because that's the stuff that you hold on to forever. And, Gen 2 collections almost never occur. In fact, if you want to go look at your collections, it's actually easy to do. I'm going to run perfmon here, right, the performance monitor that comes with Windows. And we've got performance counters that we can look at this. And you can monitor this all day long. So let's go do this. And I'm going to go in and go to my performance counters, and I'm going to go to .NET memory. There's .NET memory. And I'm going to pick PowerShell down here, because PowerShell is running, and we're going to do some work in there, because PowerShell is written in .NET. And let's look at the number of collections, right? There's some awesome performance counters in here. You should be watching these performance counters for your applications at all times in production, right? These performance counters are very cheap to look at and together, and you should have this in production at all times, because that way you can see, how big your memory's getting, what your patterns look like, so you can figure out what normal is, okay? But we're just going to look at Gen 0, 1, and 2 collections, and I'll remove the processor time there. Now, I've always maintained that if somebody would write a better perfmon, you would have pretty much everybody in the world giving you $300, because perfmon is ugly and terrible, and it's horrible. So I've been running PowerShell here, started it up, and I've run a few things from it. And you can see I've had 8 Gen 0 collections, 3 Gen 1 collections, and 1 Gen 2 collection. So this way we're going to monitor. I'm going to let the bar flip around so that we can see. We'll help it a little bit by minimizing that. Because what I want to show you is just the number of collections that occur, right? It's very easy to see these, so you can see exactly what's going on. So we'll let this spin. Once more. Come on. There we go. Now we're going to do some work in PowerShell. We're going to recurse my C drive. So I'm going to recurse all the exes on my machine. So there it's spinning away. And we can go over here and we can see our collections as they occur, right? You see I've got 153 Gen 0, wow, whopping 12 Gen 1. And hey, we actually managed to get a Gen 2 collection in there. But you can see, let me bold the lines a little bit. And so you can just watch your garbage collections. And I just wanted to do this to prove to you of that drawing that I did, that we have Gen 0 is where all the work takes place, but you have very few Gen 1s and almost no Gen 2s. And remember what I said. When something gets pushed up to Gen 2, it never gets collected because, and when I say never, remember I'm talking about computer terms, computer time. Because what does the CPU think in? Does it think in seconds? No, it thinks in nanoseconds, right? 10 to the minus 9. So when, even on big busy servers, right, that are getting hit with a ton of web traffic, you may only have 3 Gen 2 collections in the period of 5 minutes. When you're talking nanosecond scale, 5 minutes is forever. So that's why you have all of these memory problems. So that's why we care a lot about what's in our Gen 2 memory, so that we can see exactly what's going on. So I just wanted to show you kind of the generations and where they go. And what we're going to look at now is something kind of interesting, because let's talk about our generations again, and let's talk about something that happens. So we've got our garbage collected heap here, and got our generations that we just talked about. Everything's cool, everything's great, and you decide to use the greatest performance killer of them all. You guys know what the greatest performance killer of them all is? It's 3 initials, X, M, and L. The more you use XML, the more money I get to make. We love XML. XML has its place, don't get me wrong, XML is not evil, but the misuse of XML is a problem, because XML eventually has to go down to what? A gigantic string. And what's interesting about strings in .NET? They are 100% immutable. What does that mean? That means that when you have a string, and then you want to add to it or change it, the original string is released and a brand new string happens and is created. So you're not changing strings, you're creating new strings every time you do a string operation. So you decide to use XML. And XML is also like potato chips, right? Or what they call in the UK crisps. So you like your potato chips and you can't have just one. Right? Have you ever done that? You open up a bag of potato chips, and next thing you know, you've eaten half the bag. That's exactly like XML strings. So what happens here is in production, this is where the problems occur. You go allocate some XML string, and guess what? That string is 2 megabytes. You allocate this monster string, and you've got some problems. You've got some issues. Okay, so that's XML strings will eat you alive. So I got a question here, and let me go look at the... Mark Atwood has a great question. Does JSON have similar evilness as XML as far as performance is concerned? Well, Mark, this is an excellent question. A string has to be produced, and if you manipulate that string, yes. If you stick to things like JSON.NET and some of these other tools that don't produce the string until the last minute, you're not going to have too many problems. But if you start passing around, the problem people bump into is this, and I'll tell you one of the worst I've ever seen, is we had a client that wanted to build an API, an internal API that was future-proofed. So to use this API, you passed XML strings as parameters and everything else. And we were like, gosh, that's killing you because of the overall XML-ness of everything. Because XML is kind of a big fat pig, right? Because of all the angles and the angle brackets tax that you're paying. The JSON is much smaller, but it's still a string. So it's something you just pay attention to. But it's the fact that if you're going to take that JSON string and you're going to push it outside your API, that's perfectly fine. But if you're using it inside your API and you're manipulating the string by adding and removing elements from that string, that's where the problem comes in. So that's an excellent question. So it really is strings that I'm talking about, right? XML happens to be some of the worst, but what you want to do is just be careful with your strings. So great question. So back to this 2 megabyte XML string. The other problem that you have is this is a 2 megabyte string. So somebody has a reference to it. So what has to happen? Well, Gen 0 fills up. What do you get to do? You get to mem move that 2 megabyte string all through memory, right, on each garbage collection. And how much work is getting done when the garbage collector is running? Right? When a garbage collection kicks off in your application, 0 of your work is getting done. Because in Gen 0 and 1 for .NET 4.5 and higher, and prior to .NET 4.5, this was a problem even for Gen 2, they suspend all the threads, they let the garbage collector run, then they let your work continue. So if you're blocking for a long period of time, where on them moving this 2 megabyte string, you're not getting any work done. You've got a performance problem. Now, starting with .NET 4.5 and higher, they will do the Gen 2 collections on a background thread. There's your sole reason for upgrading to .NET 4.5. You can't move to that fast enough because that's a drastic performance improvement on the garbage collector. So, you kind of want to pay attention to this because really when it comes down to it, it's these big objects that kill you. Now, the folks working on the garbage collector, the designer of the garbage collector, Patrick DeSud, and his team of architects like Naomi Stevens and those folks, they're pretty smart about this. And they said, these gigantic blocks of memory are not good. We do not want to do those. We want to be smart about those. So they don't allocate what are called large objects in the normal heap. They've got a separate heap over here, appropriately enough, called the large object heap, LOH. This is where they allocate large objects. Now you're probably thinking, what's a large object? Well, I need everybody to hold up your hands. I'm going to turn on all your webcams so I can see you right now, because the last thing I want you to do is write down this number, because it could change at any time. So the .NET team did a bunch of performance tuning and a bunch of testing, and they decided, don't write this number down, 85,000 contiguous bytes is a large object. Right? They did a ton of performance tuning and felt that that was the balance. Now, if you read about the large object heap, there's a ton of misinformation out there because people say 85K. No. It's 85,000 bytes. And that's contiguous memory, like that big string, a byte array. You're right. It's not a dictionary class, right? Because you've got different pieces of that dictionary that are allocated in smaller chunks. It's contiguous memory, right? Those XML strings. Now, there's 1.5 interesting things about this large object heap. So let's go look at those. And I'm going to look at that by creating a project for you. And let's go create a little project here. And let's go just do a console app. And we'll call it console app 1. Pretty exciting. And we're going to do some fun here. So what we're going to do is I'm going to allocate an array of a byte that is over 85,000 bytes. Oops, that's not what I wanted to do. Everybody see that? And we'll do just like a string builder. Okay. Let's look at something kind of interesting. Just give me something to set a breakpoint on. So let's build that, and we'll run this. Now, there's a trick in Visual Studio that lets you do something pretty cool. Okay? That let's just take a look at what generation an object is in. So you can see I allocated that string builder, and I'm going to go over here to the watch window. And the watch window, right, and you can watch this up on Wintelect now, because I've got a whole section on this about how to call methods from the watch window. But there's this totally cool class called the GC class. And the GC class lets you get information about the garbage collector and what's going on. And they've got this really cool method called getGeneration. And what this guy lets you do is pass in a parameter, and I'll just pass in the SB. Now, based on the discussion, what's going to happen? What generation is that going to be in? Gen 0, just like you expected. So Marian Tinez has a great question here. Is there some way in which we can reliably keep track of all the GC collection times and durations? I know about GC notifications, but that doesn't work for all GC configurations. That is an excellent question, Marian, and the problem is not really. You can kind of get a feel, right? Because one of the problems, the garbage collector did not give us the granularity we need to get that information. The people who designed the garbage collector said, you should treat the garbage collector as a black box. And I appreciate their intent there, that, meaning you should just trust the garbage collector. But the problem is, what do we care about most? Memory, memory, memory. So we need hooks. So what I'm hoping is going to happen here is that now that Microsoft is open sourcing the garbage collector, I've already talked to the team, several of us have talked to the team about this. We're hoping to put some of these hooks in. But right now, we can kind of get the trends of garbage collection, but you can't look at individual ones and the times. So you can't really look at something like, let's write a unit test that uses this algorithm versus that algorithm and kind of see exactly which one takes, because we don't really have that information. But that's a good question. And I think it's something that will get addressed now that they're open sourcing the garbage collector. So let's go back to our program here. So just like you would expect, that we did that string builder and, showed up in generation 0. Now let's look at that byte array, right, the big contiguous block. Let's do the gc.get generation on that one. What generation is that? It's not what you expected, did you? Kind of expected that to be Gen 0. But, au contraire, my friends, when you allocated a large object, it goes directly to Gen 2. So that means it's held on to, even if you allocate it and immediately set the reference to null, so nobody has a reference to it, you just push that to Gen 2, and that caused some grief for you. So this is where you have a lot of the problems where you're allocating large objects, and it's putting pressure on the garbage collector, but you're using them as essentially short-lived objects. Now, sometimes you can't help that, right? I need to create this string so I can, send it to my web API so it can pass it out through JSON, right? Hey, it's perfectly normal. But this always catches people by surprise. Now, if you're using .NET 4.5 and earlier, you also have a second problem with a large object heap. That second problem with a large object heap is that the large object heap is not compacted. So what does that mean? Right? When you put objects in that large object heap, they don't compact that prior to .NET 4.5. So what happens? You can lead to fragmentation and higher memory usage, right? And very big, like the Bing team ran into this. So with .NET 4.5 and higher, they now background compact the large object heap on a Gen 2 collection. So again, another reason why moving to .NET 4.5 will make a big deal for you. Also throw in things like async and all of that, and .NET 4.5 is a pretty compelling upgrade. So there's the discussion of the garbage collector. I just wanted to make sure everybody knew about these things so that you can start kind of paying attention to it, because if you know how the garbage collector works, you're in pretty good shape. So, as we've already gotten some great questions, let's move now into, and feel free to ask any questions that you want. So what I thought I would do now is let's go look at performance in the Visual Studio Profiler. Okay, and what I'm going to do is I'm going to open up another project here. Oops. Demos. And we're going to look at an application that, because I want to show you how to use the performance tool. Okay, so that we've got, you can look at this and you can see what's going on. So this is an application, just a simple Windows Form application. And just to show you what it does, I press Control F5. This is going to prove to you that string concatenation is a lot slower than a string builder. Okay? But what we're going to do is we're going to look at this through the Visual Studio profiling tools, right? So this has got a very gross performance problem, but it's going to let me show you how to look and use these tools. So your day-to-day debugging, I want you to start using this Analyze menu because it's awesome. And this can profile almost anything that you want. And we can compare reports, and we're going to go through some of that. So let's go look at our Performance and Diagnostics Hub. And we've got a bunch of analysis that we can do. So generally these things like CPU usage, GPU usage, and memory usage, those are geared at things we're going to look at a little bit later. But we can control all of this from the Performance Wizard. So let's just do the Performance Wizard for this application, and we'll just stick with standard CPU sampling. right? Now, one of the problems you'll see with .NET, as I've been describing it, it's memory that we care about, and we've got sampling that can be used for CPU-bound problems, and none of you have CPU-bound problems. You either have an IO-bound problem or a memory problem, and we can also use instrumentation. So what's the difference? Sampling profiling is good for getting overall performance because they sample what's going on, and it's very lightweight. Instrumentation is much deeper. That gets you exact performance and exact allocation, but there's a lot of overhead with creating that. Okay? We're also going to talk about the .NET memory allocation tracking and everything else in here. Now, when it comes to sampling profiling on Windows 8 and Server 2012 and higher, we've got a little bit of a problem. And the problem is that the .NET framework is NGen, N-G-E-N. They've run NGen across it, so they have unique builds, and NGen precompiles your assemblies. So NGen is done to the .NET framework. The problem is on Windows 8 and higher, Server 2012 and higher, you now have unique binaries for each machine you run on. So what the .NET team wants you to do is to go through this process of generating the PDB files for that machine so that you can see it down to the line and into the .NET framework level. Well, the way the Visual Studio team wants you to do this is kind of dumb. And I got tired of not seeing down into the .NET framework with sampling. So what I did for you guys, if you go to code.wintellect.com and you go to the Wintellect GitHub page, you will see Wintellect PowerShell. And this is a PowerShell library I had put together. And one of the tools the commandlets that it has in Wintellect PowerShell is a simple thing that you run on each machine that you're going to profile on called add NGen PDBs. And what this will do is it will generate the correct PDB files for that particular machine and put them into your symbol cache. So this is what you have to do, because how the sampling is instrumented in Visual Studio, does its instrumentation, is through ETW, Event Tracing for Windows. So this is just kind of this really annoying step that you have to go through to ensure that you've got the correct information so you can see down into the .NET framework. And so you just have to run this on the machine. Then after you do your sampling, you can save the analyzed files so you don't need those PDBs anymore. So remember, you have to run the add NGen PDBs on each machine in order to get this information. So I'm just going to let this kind of grind through here in the background as I talk about what's going on in the rest of this wizard. So we'll just do simple sampling profiling. And notice you can do anything here. You can do ASP.NET, you can do JavaScript, you can do Xes, you can add additional projects that you want. We're just going to stick with something simple here. And I'm not going to launch the wizard because I want to talk about some of the reporting that you can do here. So we've got the properties in the Performance Explorer that we can go into, and this is where we're going to be playing around. We're going to turn on memory allocation stuff when we go look at the real-world problem. We look at the state of life as we go through here. But, we can do some work with some advanced, when we have sampling turned on, there's almost nothing you can do with Windows 8, Server 2012, and higher. But, we can control memory and stuff like that. But we're going to be playing with this view a lot. So let me make sure everything is finished there. So we did all of the work. So let's just go ahead and start, and this application will run and automatically start collecting performance information. I can start and stop. The one big benefit to the sampling profiler is that you can attach after the fact. So even though there's some problems with the sampling profiler, you'll see, we have this attach and detach. So you can get the application to a specific point, then you can do some performance runs on it by attaching, then detach, and you'll have the performance run just for the piece that you're interested in. So that's the big benefit of the sampling profiler, because it gives you that high level. So let me do string concatenation. Now let me do a string builder. And you can probably guess from the hourglass on the cursor, string concatenation isn't so good. So we'll just go ahead and shut down and take a look at this. And even if you're doing web API, web applications, ASP.NET MVC, right? What is IIS Express? It is nothing more than your simple, easy to use user application. So everything I just did with this Windows Forms application, you can do with your application. So it's pretty simple. So you can kind of see we've got some pretty good information here with our sampling profile report. You can probably guess that the red arrow here, that little section I just highlighted. By the way, you can zoom in on that if you want to. That's probably where our problems occurred, and that will recalculate the performance there. So just off this summary page, we can see a lot of good information. There's our hot path. That was the slowest path through this application, right? So from main all the way to string.concat. So I kind of think I just proved that to you. And you can see the functions doing the most individual work. And yeah, string.concat is not a good thing to call. But, so you get some pretty good overview right there. But let me show you really how you're going to use this tool. And this, what I'm about to show you, works in almost all of the other views. So the real trick is in the call tree view. Now, I've got mine set the way you need to set it, but let me get mine set. Okay. So let's talk about this view, because this is the same for memory, this is the same for allocation paths, it's the same for looking at different module views, all of the different views here. The way you're going to look for your performance problem is the same. But there's a problem. These views all have noise reduction turned on. And the problem with noise reduction is they strip out what they call the noisy stuff, very low, simple stuff that doesn't have a lot, that they don't feel, the team doesn't feel, contributes to performance. So the problem is this is going to get in the way. So what I want you to do here is, you only have to do this once, is with this noise reduction enabled, you need to turn off noise reduction. Don't trim anything, and don't enable folding. So once you've got that, now here's your algorithm, right? So we've turned off noise reduction. We are good to go. So this is really hard to do performance tuning. This is almost so easy a manager could handle it, okay? And all you have to remember is the flame button, the expand hot path. This button really needs to be red because it's so important. So you want to find your performance problem, you just simply click on this. And that's going to take you to the hottest path, either for algorithmic performance or memory, right? We use the same thing. Now, sometimes you go way down deep into the .NET framework. So all you have to do with noise reduction turned off here is start pressing the left arrow. Like that's what system.string.concat is way down deep in the framework. I want to go find where my code is. You just start left clicking until you get to your code. And the problem is that most of your code gets noise reductioned out. So that's why I want you to turn that off. So now what we can do is let's go look at the source for that. There's my line that has the performance problem. That's performance tuning. The fact that they put this flame button in here made it very easy to do. So this really opens up, I just wanted to kind of show everybody that's the big trick to using these tools. So it's pretty darn simple. So let's go dig in. Let's go look at a performance problem. And what I'm going to do is I'm going to take an open source project that I did that has some performance problems with it. And I'm just getting some permissions here so the application properly parses something. Google Chrome puts permissions on its crash reports directory, and as part of my test here, I'm going to enumerate the program files directory. So I'm just getting past this thing so we can process all the directories here. So what we're going to do is we're going to do some performance tuning on an application I've written called Paraffin. And let's open project solution. And this is an old version of Paraffin. These bugs have been fixed. And we're going to do the release build, okay? Because, hey, we want to do real performance tuning. And I'm looking at my cheat sheet here. I've got to get the command line arguments to this tool have changed, so I want to make sure I get the right thing spelled out. So we need to go into the project properties and change this. And what Paraffin is it's a tool that helps us build Windows installers. And it's a tool that helps you with Windows Installer XML. So if you've ever built an installer, you can go to the wixtoolset.org, and I wrote a tool that makes it easy to build fragment files. So this just builds a big XML file, but I wanted to take something that was open source, and I didn't have to spend 6 hours describing it for you here. So bear with me. We're going to do a directory here, and I'm going to do x86. We'll do that directory. We will do a custom attribute of xxxx. We'll generate GUID -alias -foo. Don't worry about the program too much. But let's see if I did this right. I'll build the release build of the program. And I'll press Control F5 just to make sure this worked, and it did. I didn't see an error message there. So what this program is doing is generating a gigantic XML file, is all it does. And there's an XML file for you. This enumerates all of the files, and this is going to take a little bit to open up, and it generates this properly formed XML file so that Windows Installer XML could build an installer out of all of my program files directly, right? So this is just shows a bunch of processing. But let's go do some performance tuning on this, and let's let's just go find if it's got a problem. So like with anything, what we want to do is we always want to start in the IDE. They have command line versions of these tools, very hardcore. You can even run these tools without having Visual Studio installed. We don't have time to cover all of that, but I really want people just to start running the tools. So let's just do the Performance Wizard and Performance and Diagnostics, and let's just go through this like I did to go solve these problems. So let's just start with our CPU sampling. That's what they always want to recommend for the default. And let's finish that. And, we can attach and detach, but I want to get this warmed up. So I don't want to do this every time, but how I did this for real is I run the program 3 times, right? That gets all the caches warmed up, everything done, so I'm not recording time for paging in stuff off the disk and everything else. We'll skip that process for now because, well, we don't really need it, and we'll still get to see the performance stuff. But for real, I would have run that 3 times, then done my performance run. So let's just go ahead and let this run with some sampling. There it'll run. It's pretty exciting because it's just doing a bunch of processing. But as I mentioned, as we're waiting for this to finish, as I mentioned, we do have command line tools to do all of this with VSPerf, INSTR for instrumenting, VSPerf CMD, and you can see I've got the symbol server set up because I want the best symbols possible. And here's my sampling report, and there's my hot path, right? We're recursing the files, right? Looks pretty simple. The function's doing the most individual work, right? This is an application that recurses the file system, so get internal get files, internal get directories. It makes perfect sense that we've spent over half of our time looking at these kind of exclusive samples. So I've got to define exclusive and inclusive. For the sampling profiler, exclusive means it was executing when a sample was taken. Okay, so that means that approximately 50% of the samples, one of these 2 functions was executing. Inclusive in the profiler means how much time, when inclusive means, let me back up a second, inclusive means this method was in the call stack when a sample was taken. So what do you care about most? You care about inclusive because that's your code. So let's just go over and look at the call tree view, and I'm going to sort by inclusive samples because that's what we care about. And what are we going to do? We're going to flame on, and we're going to get this kind of complicated, wow, what happened to my view there? There we go. Now we're getting the pieces. And so here we're seeing where we've got our add files and inclusive samples, but wait a minute, this recurse directories to new file was in the path more. So this is where you have to pay attention to what you're sampling on and what you're flaming on. So what I'll do is I'll just flame that, and that kind of says inclusive 12.8, 18. So that's more than the rest of them. We'll recurse, add directory nodes, recurse, right? Internal get files. So this application actually has performance problems, but this kind of shows you where the algorithmic sampling doesn't always work for you, because the process of looking at the algorithmic performance, right, it just kind of goes down to this internal get file. So what am I going to do? Am I going to rewrite, the system.io.path stuff to go, in the directory stuff? No, I'm not going to do that. So as I mentioned at the very beginning, you care about three things, and that's memory, 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 and memory. So we never actually do algorithmic profiling in the big scheme of things. We're going to use memory. Now I have some good news and I have some bad news. So here's our Performance Explorer. The good news is that you can turn on memory collection with sampling profiling. Excellent. So I can just sample and let this run. Now do you want the bad news? It's going to take hours to open up the files. When I ran Paraffin the first time, when I was doing this performance tuning, I did the sampling memory profiling. It took 45 minutes to load the data. So you're never going to use sampling with memory profiling. So I got a question here. Peter's got a great question. What would be the best way to automate this? For example, trigger the run and the profiler and then collect the results, headless, and send those results back to the standalone web app. The best way to do this, Peter, is with the command line tools. If you want to search for Studio Remote Tools, okay? So you want the latest version. You want the remote debugging and diagnostic tools. You can install these on a remote machine, and this will be all the command line tools that you can look at. And so you've got tools here like VS Perf, and I'm going to run question marks so you can see all of the help here. So everything I'm doing, let's get all of that in there so we can look at it. Everything I'm doing through the UI can be done through VS Perf CMD. So you can tell it, hey, I want to start collection with a sampling mode, and I want to do this. There's a process down here somewhere where you can specify like the process ID, the process name, you can shut down. So you would do all of this as part of probably a PowerShell script. And if you're using TFS build, you can also do this as part of the build, right? When they run unit tests, well, you can turn on performance collection in the unit test, and they will automatically do all of this stuff for you. Now, you have to have the remote tools on the machine. But this way, you can just start generating those tests, and I'd really encourage you to do it because it's, once you get used to the patterns, it's not real hard. But you can start and you can attach, right, with the sampling profiling here, so you can say, let's go attach to that process and just do a sampling run. And I do that, a lot of my build scenarios, just as we're running unit tests or any kind of smoke test, we just do algorithmic profiling. That's just going to give us a vague idea of where some of the hot spots were. So that gives us a direction to explore. Now, we can't look at memory when it comes to sampling profiling, but the fact that I can attach and detach from process, I can do great things, right? I can script this where I've got like a PowerShell script, starts up the app, or it starts with an IIS reset, gets the app warmed up, then it attaches, then we're getting performance runs just for the new stuff, for example, that we've added the code. So we've got a lot of control with VS Perf CMD. That does a lot of the work. So just grab that from the remote tools. And those tools are installed with Visual Studio. So if you've got Visual Studio on the machine, you can just turn around and start generating the data straight from the command line on your machine. So you can debug the tasks and get them all working directly. So great question. So let's go back to our memory profiling, because that's really what we want to do. So good news, we can do it. The bad news, you're never going to do it because it's bad. It just doesn't work that well. But what we're going to do is instrumentation. This is the important thing, because we're going to instrument the binaries, because this goes one level deep into the framework, but it does catch all of the memory that if you call into some third-party component like the framework or Infogistics or something like that, and you're going to see that memory the total memory come back for your code. So this is really the important one. The other big news here is that this doesn't take a whole lot to run. It adds to the overhead of the run, but the files open relatively quickly and so on. And we can also look for object lifetime information. So I'll go ahead and turn this on, and at the end, let's make sure I take a look at that. But what this will allow you to do is see which objects are pushed up to Gen 2. So you'll see for this particular type, this is how many bytes were in Gen 1, this is how many bytes ended up in Gen 2. So you can see, your generations there. Now, since we are doing instrumentation, we've got some stuff we have to think about, because if you're strong naming or digitally signing your binaries, what's going to happen after you instrument? Those binaries are never going to run. So this way, if you're strong naming your assemblies, you're going to have to do some stuff after the instrumentation with the pre and post events, generally the post event, that is going to re-sign your binaries, right? So you're going to have to write a batch file here and have it run so you re-sign. I don't want to get into the discussion of strong naming, but strong naming is kind of pointless, to be honest with you. But, so your day-to-day development, you don't really need it. And you really should be using the GAC. So I know some of you are thinking, well, if I'm installing stuff in the global assembly cache, they need to be strong named. And my response is, why are you putting anything in the GAC? It's just, disk space is cheap. Just have a direct reference. That way you don't have the versioning problems and all the other problems with the GAC. So anyway, if you're doing strong naming, you need to instrument after the fact. So it's pretty straightforward to get set up. Since we're instrumenting, that's going to open up the possibilities to grab Windows counters, and you're going to see me take a look at these. All performance counters will be grabbed when you use instrumentation. So this way you can do some work there. We can see Windows events, ETW tracing if you wanted to see that, and a whole bunch of other things. And everything, like I said, everything I'm showing you here, you can do with the command line. But I just want you guys to run this day to day, because as you're doing development, as you get, okay, I'm done with this feature, let's just go do some performance runs, because you're going to find out most of your stuff is pretty simple. It's just go find the low-hanging fruit, which is exactly what we're going to do here. So great, let's go do a performance run now that we've got instrumentation turned on. This application doesn't use any strong signing, so let's make sure it's all built. And we'll get Performance Explorer, I thought I had that pinned. And let's go ahead and give it the first run. So let's just start profiling. And so this is going to generate performance data for the entire run. Okay, pretty simple, pretty straightforward. If anybody wants to do an interpretive dance of gathering performance data, this would be the time to do it. Here, I'm dancing now. I won't turn my video on so you can't see it. But, it takes a little bit. We're running the live meeting here. I forgot which tool we were using. And so it's taking up a little bit of the time. So, we're seeing a little hit because of the live meeting with the VoIP and the screen sharing. But, we'll generate our performance data here. This will take a little bit. This is a good time if anybody's got any questions.
Come on, everybody. We know you've got loads of burning questions. I've already asked one.
Yeah, so Peter gets a gold star for the day. But, this analyzing the report, this is where they're building up. Because we turned on the object lifetime stuff, that's making the report a little bit slower because it's building up which objects went into which generation. So there's a lot of data with these reports. They're not the smallest things in the world. So here's our VSP file. This is where we've got the data. And now that we've turned on allocations, we're seeing functions allocating the most memory and the most types, and the types with the most allocated, the most instances. Now, these make a lot of sense when you look at types with the most memory allocated and types with the most instances. This is an application that produces strings, so that makes perfect sense. And you can see that our big memory was getting files and getting directories. So we got a couple of questions here. Michael, I am breakdancing. You didn't even. I was spinning on my head. So you missed it. I guess I should have turned my do this. So Brian's got a great question here. At what part of the application life cycle would you suggest developers start performance tuning? As the saying goes, premature optimization is the root of all evil, I think, right? Do you remember Donald Knuth said that? I would say you start your performance tuning as soon as you have something that you can run, right? So you do a module that, say it's a web API that's starting to just produce some data back and forth. Start running some performance tests, because as you're going to see as I go through here and we look at the performance issues, it's all low-hanging fruit. And you'd be surprised if you just run this a couple of times on your applications, you're going to knock out some big performance problems. So I would say pretty early in the process, right? Because performance is a feature. Where that quote comes from is that when people, when they're writing the code, try to get too fancy. Get something working first, then go take a look at the performance. Because simpler is always better, but it's that premature, let's overthink this as we're writing it. No. Just get something working, then go see what the tools tell you, right? Rico Mariani says the key to performance tuning is to measure, 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 right? So there's your deal there. So Chris has got a great question. Do I benefit from all the 4.5 CLR improvements for applications compiled against version 4 if only the 4.5 runtime is installed? Yes. Because they install over top. So if you've installed the 4.5 runtime, and that's the only runtime installed on the machine, right? Because it installs into the 4.0 directory, you're going to get those benefits. But what's the other stuff for 4.5 that's the big stuff? Async. Right? It makes it so much easier to write async code. So you want to target 4.5 to get the big benefit. But if 4.5 is on the machine, that's going to help you out. So you're going to get that benefit. Yeah, exactly. Part of the reason why I picked this simple app like this is Peter's got a great question here. So far you've shown us perf tuning on a single monolithic app. Surely this gets way more insane with apps that are dynamically loading stuff, such that are apps that are using MAF, MEF, or MEF. What about crazy scenarios with DR-based languages? Well, guess what? It's all pretty much the same, because you can pick when you choose what to instrument. In fact, before we get into this analysis, right, notice here are the targets. I can always go add additional binaries, and if I had additional projects in here, I could add those. So you could literally, inside Visual Studio, just target that one MEF component that you care about, right? A lot of us are starting to write, are getting very interested in Wintellect analyzers, right? If we go back to the code.wintellect.com, one of the things that we just posted at Wintellect is the new Roslyn compilers has these really cool analyzers that let you look for errors in the code as you're typing it. So these are MEF plugins, and what I would do is that I would set up Visual Studio, and I would just say, go only instrument this Wintellect.analyzers, don't instrument anything else. So even though that's fully pulled in by MEF, and it's a MEF component, I don't care, it's just a DLL. Now, if you want to do things on a machine where Visual Studio is not installed, getting some of the benefit, or playing around with vsperfcmd.exe gets to be sometimes a little hard. So sometimes it's a little bit of a problem. So, anyway, so Martin's got a great question here. Isn't it possible to watch garbage collection ETW events to see which garbage collection is triggered? And he's got a link here. And I think Martin is correct here. They don't. What I was referring to is they don't make it super easy to do this inside Visual Studio in Perfmon. And let's look at the link that Martin sent along. Yeah, so we do have these ETW events, and Martin's exactly right. You can look at this, but we don't have a viewer for this. That's the problem with ETW. We know we have all of these awesome events. So Microsoft has put all of these events in, but we don't have a way inside Visual Studio that would say, give me a view like this and say what garbage collections occurred between those 2 points and show me how long they took. So that's what I was referring to, but the information's there. We don't have good viewers on it. Now, there are tools like Vance Morrison's, if you really want to get into this. If you really want to see that, Vance Morrison, he's the performance lead for allthings.net. And in fact, he just released a new version of this. You can get that ETW in this tool here, but it's This is an awesome tool, just very hard to use. And for your average developer, it's just a bunch of noise. That's why I don't really talk about it. But that's how you could get that information. So Martin's got a really good point here, and hopefully we can collect that question and keep it as part of the LIDNUG view. But here's the event he was talking about. But you see, the problem is we don't have an easy way to view it. So we can get this, and this tells you the time, the generation. But until we've got a tool that makes visualizing ETW great, it's not real hard. In fact, if you're really into this, there's another tool that can be used to view this information. So up at LIDNUG now, we have the tools here. Let me log in. And we're very fortunate to have a whole course, a 3-section course, on event tracing for Windows. And this is by Bruce Dawson. And he's one of my personal heroes. I just feel so lucky to know Bruce. Bruce Dawson was a performance engineer on Internet Explorer. He was the performance lead for Valve. Now he's the performance lead for something almost all of you use. It's this browser right here called Chrome. And so he's the perf lead at Google now for this. And he put together a whole section on how to use event tracing for Windows for pretty low-level stuff. This is really hardcore. Okay, but if you wanted to see those garbage collections, he shows you how to use the Windows Performance Toolkit to get that information. Okay, I highly recommend getting a LIDNUG Now license just for this ETW course because it is complete gold, folks. This is hardcore stuff. Okay, so great questions. So let's go back and look at our memory. So we've got our views there, and the key thing that you want to look for here in these functions allocating most memory is you want to look for your functions. Because if you see your functions in the top 5, you've got a problem. That's a very simple way to look. So let's go look and do our memory analysis on the call tree. And notice that we've got the inclusive allocations, the inclusive bytes. I just care about allocations and bytes. We can sort on either one of those. And let's flame on, my friends. And we'll flame down, and we can see that inclusive bytes, add new files to directory node. We'll flame on that. Then we've got get files. There's not a lot we can do about that, so I'm going to look at the second one here, the create component element. Flame on there. There's my create 70 char ID string. That's what it's complaining about. Let's flame that. And what do you see? Okay. Things are sorted here. So what it's complaining about is most of the allocations, it's saying 23 million of these inclusive bytes of the 74 million came from that allocation right there. See how easy that was? You just flame your way down to your memory problem. So this is complaining that that text string builder right there is the problem. So let's go view the source here. And what is it complaining about? It's complaining about that line right there. All right, everybody see that? I'm just telling you exactly what the tool told me. There's my code. There's the thing it said was the biggest. That's the first thing I want to go fix. That's all we do. So what I'm going to do here is let's go back to main, and it's complaining that this is allocating too much. So, well, this is a static method, right? Guess what I should do with this? What I should be doing with this, according to the rules here, what the tool told me, I should be making this a static. And down here, what I should be doing is reusing it, just like that. So I am literally doing what the tool told me to do. It said this was the problem. That's it. That's the low-hanging fruit. Okay? So we just moved that out, made it static, and we're going to reuse it. Okay? So let's go take a look and let's rebuild my app. Do at least one run to get the cache warmed up. Pretty excited. And let's just go run our profiling again. And so this is your process, right? Go see what the tool tells you on that flame and go fix it. That's all we did there. This is pretty exciting to watch here. But I'm also stressing this application by having it do all of the program files directory because there's a lot of stuff in program files. So I'm just having it do a ton of that work in there. Right, that's another thing that you're going to have to do is probably go figure out how to do some gigantic data sets so that you can, stress the code enough to see where the problems are. So that's another thing, and that's why I picked the program files x86 directory to get that level of stress. Okay, so any questions? Pretty exciting watching that bar go. Maybe they need to performance tune this. Well, before I jump in to looking at this, we want to see, did we improve anything? So let me show you a cool little trick here. I just control-clicked these two files, right? The first one was my baseline. The second one was the one we just ran. So I'm going to right-click here. Let's compare those reports. And what I can do here is, look, I don't care about exclusive. Exclusive means nothing when it comes to memory. I care about inclusive, right? So we'll do that. And this is a bug where they don't particularly there's a button back there that says compare, but since I have the presentation fonts on, this is messed up. But here's the important thing about the comparison. More green lines going down, the better off you are. And this is showing that we reduced the memory difference, and if we go to main, you can see the big one, right? I knocked off, what, a little less than 100 million bytes by just taking care and making that one thing static and reusing it instead of allocating it every time. Yeah, Chris, this is an excellent question, and it's actually something I looked at in other versions of Paraffin, later versions. If you do go down to the Windows API, it gets a lot faster. So, if this was a super performant application, I would replace that. But you've got a very good point. The tool directly pointed us at those get files, and by grabbing them and doing the file I/O on our own, we improved the performance considerably. Okay? So good point. Brian is asking, would it be advisable to have a dedicated test or analyzer machine doing the test analysis, or can you fully trust using local? For the memory stuff, Brian, local's been good enough. The one problem you have with local is sometimes you don't have big enough data to really stress something. So, sometimes what you'll have to do is maybe change connection strings to point at some test data in a database so you're getting enough stuff so that you're seeing what happens under stress. But for your day-to-day development, I've had very good luck just doing it locally. Now, when you get serious about performance and you're like, what is overall system performance? That's when you're gonna want to have some dedicated machines to really stress those. But just let's look at the performance, look at the memory problems for this component. This is good enough just doing it locally. Well, Patrice has a great question. How do the Visual Studio tools compare with dedicated commercial apps like Redgate or JetBrains? When would you use one of those? I'm going to show you where the Scitech tool comes into play. I've used all of the tools. In fact, if you look on my machine, see, I have the Redgate tools. I have the .NET memory profiler we're going to talk about, right? There's the memory profiler. At one point, I had the JetBrains tools. All of the tools have different good scenarios because, like the Redgate tools, I think are extremely good for developers who are not that senior, right? Kind of junior level developers. It makes it really easy to find performance problems. And we've had great luck when we've gone into done consulting and we're trying to build an environment that believes in performance by giving the Redgate tools to newer hires. The main reason I'm concentrating on the Visual Studio tools here is that's the one tool I know everybody's going to have access to. So at a minimum, you have that. When it comes to the .NET Memory Profiler, you're going to see some particular reasons why that's fantastic, and I'll get into that in a little bit later. Peter, Peter's saying, any chance you got custom object examples? Yes, you're going to see some here as this example. He appreciates the string builder example, but, most of us are dealing with something other than plain strings. I have an app, for example, that deals with 1.2 million mapping objects in memory, and I'd like to see how that might be handled with custom objects. Well, here's the good news, Peter. Everything that you're seeing, this just happens to be an app that uses a lot of strings. Guess what? Your 1.2 million objects are going to show up here just the same way. The same process that we're doing with this application, which is simple enough we can get our head around it, and I don't have to spend 2 hours describing the architecture, the exact same process you're going to do with that big app. Yeah, we're almost never dealing with strings unless you're dealing with an application that's producing a lot of them. But I just happen to be using a string here. Could be anything else for that matter. That's the good news about the tool here, and that's and if I didn't make that clear, I apologize, but the same process we're using with this is the same process we're going to use with everything else. In fact, we're going to see here, as I keep going, we're going to see some pretty interesting examples of stuff that where we do have performance problems that are not related to my code. Okay, but it's the way I'm using things. So just trust me, this works. It doesn't matter what type of app you have. So great. We improved memory. We reduced our overall allocations. And anytime the garbage collector is doing less work, the faster we are. So that's pretty cool, right? Real simple little run there. We got to see that. Now, one thing before we move on to fixing this problem here, let's go look at, the call tree. We got to go find where it's complaining now. So it's complaining, let's get all the inclusive out. Let's get this sorted by inclusive allocations. So that one's a little bit bigger. We'll flame that. Get files can't do much about. Create component element is the one in our code. There's creates every care ID string still. It's there. Now it's complaining about the system.string.format. Okay, so there's where it's saying that there's about 200,000 allocations of the almost million allocations are coming from. So let's go look at our code and see what we can do to fix that. So it's complaining about the string.format, which is that guy right there. How could we fix that? Because this is, oops, didn't want to do that because we want our unique string. How I fix this, let's avoid the string.format because I'm just getting the unique ID there. How about we do this? Would that do the same thing that commented out code is doing? Yeah. Right, so I'm just doing exactly what the tool told me to do. And like Peter's saying, if you've got that thing caching 1.2 million objects, just run some runs on your machine, do what the tool says, because the tool is very, very good at figuring out where those issues are. So, oops. I know what that crash is. Remember, I was in here playing with the crash reports directory? Yeah, because I'd used Google Chrome, and so it reset the permissions on that directory. So let's make sure that we can go in there. Okay, so now we can start profiling again. But yeah, just start running this on your code because when I've gone in and looked at all these big problems, it literally turns out you fix 3 or 4 of these low-hanging fruit things, you can easily get a 15–20% performance boost, because especially if you look at the memory, and it's always going to turn out to be things that are kind of non-intuitive. Like if I would have shown you that create 70 care ID strings, you would have looked at that and said, "Oh wow, that looks good." But it had these memory problems with it, and that's what you find is it, and it's going to be someplace where you don't expect it. That's the really interesting thing. And so we'll dig in here. We've got one more of these to look at. And I think that you'll be kind of surprised at how we go about finding the next one. As we let this grind away here. Pretty exciting to watch that spin up. There we go. Of course, we want to make sure that we did some good work, so we'll compare our VSP files. And we care about inclusive. We don't care about anything else. And, you know, here's our main here. All right, so we're getting quite a bit different numbers of allocations, more green arrows, good stuff. Now, these VSP files are, this is the raw data. So every time you open up one of these files, it's going to reanalyze this file, which is kind of a pain because if you're on one machine and you want to give this file to somebody else, they're going to have all the exact matching PDBs and everything else. So one of the important things you can do here is save an analyzed report. So if we save this analyzed report, it doesn't have to do any analysis. It essentially opens almost immediately. So if you're going to take reports from machine to machine, or check them, or attach them to a bug report, or put them up on your wiki about performance tuning tricks that you've learned, save the analyzed reports because the VSPS files are what you're going to want to pass around to folks. One other thing before we look at this run here, I want to talk about the marks, because we have when the performance is being captured, they're capturing all these performance counters. And what's kind of cool here is that you can build up filters that say, I want to filter between various points. So if I just cared about, even your own performance counters can be shown in here. So I kind of see a big jump of memory between here and here. I can select it and add a filter based on the mark. So I can do a custom filter so that we can filter down the pieces and just look for general areas of our app. In fact, we had a large application that we did some performance tuning on that took quite a bit, like the application Peter's talking about with the tons of data. So what we did is we ran the application. We just ran it under Visual Studio, and what we did, which was pretty cool, is let's turn off full screen. Is VSPerf CMD has a marks option with it. So what we did here is from the command line, we introduced a mark. And what we did, because this application took so long to get started, it was a big, giant application, and we wanted to do 4 distinct different runs of performance. But by the time everything got started, everything got warmed up, we didn't want to shut this thing down after the first run, then take another 20 minutes to get the second run. So what we did is we just kept the app running. And what I would do is at the command line, I'd interject a mark at starting this performance run, then go do that run, then I did a mark for the stop. Then I do another mark for a start. Then I do another mark for the start. And what we were able to do is that we were able to go in here, and then I would extract out the individual. I built a filter for each of those individual 4 pieces. Then I'd save those to VSPS files. Then we could look at all 4 pieces of that overall run in isolation. We could do comparisons and everything else. And that was just a nice way of dealing with a large application. So we got a question here. It's a good question, Brian. So we've seen what we can use the analyzer for. When should it not be used? What should the developer be cautious about? I think the caution is more around the cases where you're not pumping enough data in. Because, if I would run this on more normal directories, you'd start seeing other areas showing up having memory problems. So you want to be cautious that you're ensuring that you're pumping enough data in the right kind of data that's going to stress the code. That's what you have to be cautious of, because I've seen folks, they'll have a database of 10 items, they'll run that and say, here's where my performance problem is, and then they go into production and they still have really bad performance because they're not seeing sufficiently the real stress. So, a lot of this performance tuning is that you have to get data that's going to stress the system enough to surface up those kind of garbage collector memory problems. So that's where my caution is, right? I've had folks say, hey, I found this performance problem, and I look at it and go, who cares about that? But we're seeing these problems in production that we know are related to this database query here. So we want to put enough data that that database query is pulling back 1 million records so we can see how we're processing it. Okay? So it's more about the data going in. So great, right? We just did our first performance hit there. And let's Alt-Shift, Enter. Come on. Go back. Sometimes there we go. Sometimes in the keystroke here, it doesn't trigger up. Okay. So let's go do our performance tuning again. Same thing as we've done with our call view. We don't need the filter. Let's flame through. Oh, inclusive allocations will be good enough. Add new files. That's the big one. Flame through. Get files. Can't do anything about that. Create component element. There's create 70-char ID string. That's the big one. We'll flame that. And I want you to look closely here. Okay. You see those 3 lines? Do those 3 lines add up to 6,938,496,000 allocations? I don't think so. Okay. You can see this better if you look at the inclusive bytes. Okay. Here's inclusive bytes. Does this add up to 42 million bytes? I don't think so. Okay. So this is a release build. So some interesting things happen. So sometimes this view doesn't show you everything. And so what we're going to do is I'm going to go back to the summary, and we'll start at a higher level, right? We'll look to see your functions allocating the most memory. It's saying that create 70-char ID string is still allocating a ton of memory. But, is it? So let's look here. Let's look at the types with the most allocated memory, the types with the most instances. And, it kind of makes sense. We've got all these strings, characters, XML attributes, object arrays, string arrays. I don't know about you, but regular expressions jumping out are a little odd. So let's look at another view. Oops, I didn't mean to do that. Sorry. So another view that you want to look at is the allocation view. By the way, here's the object lifetime view. This is where you can look at the different generations, which objects appeared in which generations, so you can just get that feel. But let's go look at our allocation view here. And, I'm going to sort by inclusive bytes here because, that's what I'm interested in. And, 500 million strings seems reasonable, 55 million string arrays, 52 million X attributes seem reasonable. 41 million object arrays, then we get a regular expression. So there's more regular expressions than X elements and int arrays. And hey, while there's regular expression matches, there's more of those than characters and character arrays. That's kind of weird. So, the other way to look at this is just look at your allocations and you kind of look at the most allocated things. So what are we going to do? Who's allocating this regex? We're going to flame on. Same exact process, right? That was the one thing that jumped out that looked a little odd. So we're seeing that, add new files to directory node, right? Just flame on, create component element, flame on, create 70-char ID string. It says this is where almost all of these are getting allocated. Well, let's go back and look at my code. Do I have it? You can see the entire method on the screen. Do I have anything here that allocates a regex? Well, we don't, but I have one method call here that does go into the system. And what just happened? What did we just see in the run? If we go back to where we were, so there, oops, I just blew past it there. There's my remove invalid characters, right? There's that call. Wow, that called regex.replace. Regex.replace, what does that do? Well, that's why we all have reflector. Oops. Regex. There's the view that I want. Okay. So there's regex, and we've got replace in here somewhere. I just called regex.replace. And I called which one? Regex.replace string, 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 3 strings. So replace string, that one. Wow. So regex.replace, the 3 strings, calls replace, which does what? Ooh, look at that. It allocates a new regex. So this is just a great example where you using a third-party library or the framework class library, it comes and hurts you. Because I've got this static method I'm calling regex.replace, and what I don't realize is just how much memory this thing is allocating behind the scenes on me. But the tool told me exactly what I had to look at. So we've got an inline method here. That's why there's a little bit of a bug that they don't show the inlines all the way correctly. So again, I want to get this because I don't want to allocate this all the time. So I'm going to regex. And I want the pattern one. What did I do? Okay, there's that. And now that I've got around and I've kept the 1, input, and I want that one, replacement. Okay? So you see, I'm just doing what the tool told me to do. Nothing fancy. Let's build that. Make sure it builds. Okay. And I'm just going to fire up another run and let it go. So this simple application right here took me about 45 minutes or so to go through this. But what did we see? Right? We just saw to look at the data to pull down the calls view and the memory view and flame down to the stuff that we needed to see. And we just found 3 problems. Now, I went through and I was doing a lot of explaining. How long did this really take to go look at in the overall scheme of things if I was doing this without presenting it? What, about 5-10 minutes? Right? That's what's kind of interesting about this. And so Peter, go run your giant application under this. Let's just see what happens when you instrument everything and just get pointed at stuff. Start with that sampling profiling, just see if anything obvious comes out. And as you start digging into individual assemblies, you're going to see very obvious things very quickly. And let's validate that we did improve memory, right? Let's compare our files. Oops, I clicked the wrong one. Sorry about that. Because I have the sampling one and the instrumentation one, and they don't like that. So you got to have both instrumentation. Let's just do inclusive bytes percent because that's the easiest one to find. And I improved overall 13%. And if we look at main's should be in here somewhere. Anyway, you can see that create 70 char ID string, I had 13% improvement. But what are we after here? What are we after? We are truly after overall performance. So let's look at something important. So this took 33 seconds when I first ran it. This is the very first run that we did with this guy right here. And the very last run took what? Less than 29 seconds. So think about that. In about 10 minutes, I improved this overall run by over 10%. Does everybody see that? That's the important thing I want to take away, and this is why you care about memory, because of all of the allocations that you're doing. It's a big surprise that simple things like, hey, this is static, this is being allocated all the time, so there's more work in the garbage collector. Let's make that static. Now, now we've got multi-threading and other things to worry about there, but that's a pretty good performance boost for simple stuff. So Doug's got a good question here. What would you recommend for additional reading material on this subject? Well, take your free view of Intellect Now, and I've got the full performance class up there that goes through everything. There's also a book by, oh gosh, is it A Press? Oh, wait a minute. I've got this thing called the electronic version. OneDrive. Hold on. Let me get the book. On Windows, it's not that hard. Pro.NET Performance. Duh. This book right here. I thought I got, this is the early version. It's called Pro.NET Performance by Sasha Goldstein. It's fantastic. And he goes into a lot of really hardcore stuff, but it really gives you, because it all comes down to the CPU at some point. And he does a very good job going into a lot of this. So between those two resources are good. Yes, the Redgate books, the Redgate memory profiling books are absolutely outstanding because they concentrate on memory, and they're really good examples of using the tools as well. But there's a bunch of good resources out there, and thanks for bringing that up, Peter, because man, those Redgate books are good. I contributed to one of them, but they're really good stuff. But I hope you saw that without a whole lot of work, man, this is where you get raises. This is where you get promotions. Hey, boss, I got a 10% performance boost on the application. Chris has got a good question here. We have a huge question of small objects. How much would we gain or lose from using value types, structs, instead of reference types for the small objects inside the collections? It would. That's an interesting question because it's around arrays. That really, if you're putting them into arrays, the direct reference in arrays for structure types is drastically faster than reference types. And if you take the full performance class at Intellect Now, watch the section on the performance of everyday things. We go through a ton of examples with small performance things where we compare the performance of object reference types versus value types, and you can see a lot of information about that. But it's really around array access is where that's really good. What about memory leak tracking? Would you go through the same process, or are there other cool tricks? Patrice, actually, the next thing I want to show, and I know I've gone long, but I'm going to get everything done. Okay, so when it comes to memory leaks, okay, there's if I suspect that it's and what's a memory leak in .NET? That's where you're holding on to objects longer than you expect, and causing memory pressure that way. So this tool, the Visual Studio tool, everybody has, and it's good for looking at your day-to-day stuff. But when it comes to memory leaks, what I'm going to look for is a commercial tool, memprofiler.com. This is the Scitech.NET Memory Profiler. And this is a tool that makes looking at memory in some ways a little bit easier, but especially looking for those memory leaks, right, are very good. Okay, there's somebody got a partial question in there. But this is a great tool. So this is the tool I want to show you now. And this tool can look at almost anything you can imagine. And there's two versions of this tool. You really, really want to spring for the professional edition. And the reason you want to spring for the professional edition is the import memory dump. Because this can, if you take a memory dump of a production server, this will open it up and show you your memory problems and allow you to compare sessions and things like that. So the fact that this can work with mini dumps is incredibly important. But it's also very good day-to-day stuff. Okay, so, but it's the memory dump analysis that's real good. Visual Studio can't help you at all with that. On average, what would be a performance penalty of using .NET Reflection to interrogate objects? It depends on the .NET version. With .NET Runtime 2.0 and prior, it sucked. They drastically rewrote the reflection with .NET 4, so you're going to see a massive performance improvement. Now, reflection is not free, okay? But if you have to do it, you have to do it, but you want to be smart about it, right? So, but it's something you want to pay close attention to, because if you end up doing a lot of it, it can hit you. But moving to .NET 4 drastically, they rewrote reflection from basically the ground up. And so many of the people that had problems with reflection, just moving to .NET 4 was enough for them. And most folks, reflection's not much of a performance issue these days, where it used to be in the past. That was one of the key things we look for. We don't look for it too much anymore. So as you can tell, this .NET Memory Profiler looks at almost everything that you can imagine. XEs, ASP.NET apps, even Silverlight apps, Windows Store apps, like anybody's doing a whole lot of those. But what I want to show you is I've got an application here, and it's a Windows Forms application to keep it simple. So here's the fixed version of it, and for reasons that I'm not quite sure why I did it, the original version is called 2, so go ahead and laugh at me. I should. So this is the old version, and this is the new version, okay? So I'm going to do a simple bubble sort. We'll let them both run. And if you had the code for these and you played with it, you'd notice something pretty interesting. The animated algorithm 2, which is the original version, it is on average 27% slower than the fixed version. If you look at all of these sorts, all different ways, do the analysis, it's a whole bunch slower. So Visual Studio can kind of point you in the direction of this, but this shows that the example using the Scitech tool is the big thing here, because the Visual Studio instrumentation really only goes one level deep into the framework. You get the total sum, but you don't get to see all of the issues. So let's look at the Scitech Memory Profiler, and you can see it profiles anything, and we'll just do animated algorithm 2 here. And you can do different levels of profiling. Medium is good for your day-to-day stuff. By the way, there's a command line version of this Scitech tool, so you can run this on machines that don't have Visual Studio or Scitech installed. If you're dealing with app domains, you can play with that. It also does native memory, GDI handles, C++ memory, things like that. And I do want per instance data here, so that'll add some overhead. And let's go ahead and start the app and let it run. But as I mentioned, this Scitech tool is very good for very deep memory analysis and very deep memory leak analysis. And I think this demo really shows if you run the same thing in Visual Studio, we wouldn't see a whole lot. So I'm just going to let it sit. We got works on taking snapshots. So you grab a snapshot of the heap and you look, and then we're going to compare this to a different run. So that's pretty cool. We've got our snapshot, and so let's just do a couple of sorts here. Let me close down to make sure I get the right instance here. Okay, I didn't mess anything up. So this is pretty cool. So let's just do various sorts. So I can bidirectional bubble sort. That's pretty exciting. Isn't that awesome? And we'll do a fast quick sort. And that's probably not coming through very well with the live meeting screen sharing, but this is a beautiful application that I always loved how there's to see how algorithms sorted. And you see how they get built up. So I wrote one on a plane to India. It kept, I can't sleep on planes, so this gave me something to do. So bubble with quick sort. Well, I'm just doing a bunch of short sorts here to generate a bunch of data. And there we go. And now we'll take another snapshot. And here's where we get to look at memory leaks, because we compare snapshots. And you always want to sort by the delta column. And you see very quickly is GC handle is the biggest change. And GC handle is a special table that .NET uses to store p-invoke data. So when you p-invoke to a native API, they actually hold a reference when you do the actual p-invoke, because you could always release your reference. Then native code's got this memory that it's writing to, which has been released, and it would cause a lot of problems. So the GC handle is that let's keep a reference to this in case the developer lost a reference. So not too big a deal on that, but I got a weak reference? What the heck is going on there? Well, what's a weak reference? Right? Almost nobody knows. A weak reference is a reference that's weak. How do you like that tautology? But the idea here is that a weak reference is used so you can reference an object but allow that object to be garbage collected. which doesn't make a lot of sense unless you start thinking about caches, right? So caches are implemented using weak references. So anytime you see weak references, you're potentially looking at a cache, okay? So that's our problem. So let's go look at those types. I'm just going to double click on it. And the important thing here is the allocation stacks. This is what I always look at. This is going to show you the most common allocation stack for this particular object. So let's close down this solution and open up Animated Algorithm 2. Because what we're seeing in the tool is it's saying this sorter graph update single fixed element. These bars here indicate the source code is available. And so we've got a couple of these. So here's what it's complaining about, this update single fixed element. And if I showed you this, if you did a code review on this, you'd probably look at that and say, that looks pretty decent, doesn't it? This has a tremendous memory leak in it. And so Patrice was asking about memory leaks. This has got a gigantic memory leak, and the Scitech tool literally points you right at it, because we did that diff, and we're like, wow, this has got 100,000 more of these for over 2.5 million bytes. Right? I just did 3 or 4 sorts there. I didn't do a whole lot. So I took a big, giant hit on my live bytes, and you can see total hell, and you can see that this grew up. And what's going on? Well, the update single fixed element is in here creating a solid brush, and it says that's what the problem is. So let's pull up Reflector again. Oh, I've got Reflector right there. Let's search for solid brush a little bit. I really should move to dot peak. There's a solid brush. Here's the public constructor that takes a color. Oops, right, that takes a color, and it's complaining about. Anybody see anything interesting in the code there? There's your solid brush constructor. It complains about the system color tracker.add, and if we go look at that method, well, what's going on there? There's my weak reference. So why am I leaking these weak references all over the place? It add up to a big chunk of memory. Well, what can happen with the solid brush, right? And especially a solid brush that is a system color, because that's where that triggered. So they're tracking these because a solid brush can change as you're running your application. And they're doing a very nice thing for you here. Very nice thing for you here. They're setting up an event handler that if they want to cache these brushes, because if your background brush changes, they're going to replace the brush for you. That's awful nice of them, isn't it? But what did I do in the code over here? So I was allocating these things. This is causing a massive memory leak that you would never see, but you would see your applications using a lot of memory. But the framework was trying to do a good thing. I misused the hell out of it. So we've got a big memory leak here. So the overhead of creating and tracking and keeping those solid brushes and the cache that they're put in, that causes my sorts to be 27% slower. I would have guessed, because I had seen this, how the solid brush does this work for you, so I wrote the code purposely this way to kind of be a little problematic. And I would have said, maybe 4 or 5%. The 27% surprised the heck out of me. I ran thousands of runs to validate that was that using that kind of memory was the problem. So the fact that we've got a tool that helps us look for those is pretty neat. And we also can look down at the tool for down particular instances of objects. We can let's go look for Yeah, just do this. So we can look down at individual instances. You get this nice graph over here, but you get to see all sorts of detail about individual objects. So you can see how they got referenced, who's referencing, and so on. Another thing you can see with this is the actual raw instances, and one of my favorite little views is this age column here, because this age column tells you how many garbage collections that particular object survived. So when Patrice was asking, hey, how can I look for memory leaks? Well, you're looking for a particular type that's been sticking around a long time. I just go look for a particular type and say, sort by age, who's referencing those particular guys? Why would they still be in memory? And what are all your memory leaks in .NET? You've got some static fields you didn't realize was static, or you've got an event handler that you didn't realize was holding on to some UI element or something like that. So, that's what you always look for, to look through your memory leaks. But I've shown you a whopping 5% of this tool. The other thing I like about this tool is the real-time view, because we can look at live bytes, and then, total bytes, I'm sorry. That shows us our actual memory allocations. And if you look very closely, there's some lines there. That's where I took the memory snapshots, but if you look real close, you would see that they've got numbers above them, and that's showing when different garbage collections triggered. And those happen to be Gen 2 collections because I did a full memory snapshot. But this way you can look at your application and kind of see when your garbage collections occur in real time. And that's kind of interesting when you got that web app up and you're monitoring it and you're doing Operation X, Operation Y, and you say, gosh, I do Operation Y and I see, 27 Gen 2 collections. What the hell are we doing in there that would cause all of those collections? And so I've done a lot of performance tuning just with this graph. So I just wanted to show you, memory leaks and why you would use the Scitech tool. It's the tool I turn to for a lot of those kind of problems, and it's worth knowing about. And by the way, I don't get any money from the Scitech guys for telling you about it. The only contact I've ever had with them is giving them my credit card. But we've got the Redgate tools, you got the JetBrains tools. All of these tools are excellent. Start using them because I think you'll be better off. So, sorry for going a little bit long here. I got excited and talking about stuff, and as usual, planning too much stuff. But I'll stick around. If anybody's got any questions, I want to remind everybody to take advantage of the John R-2013. Would love to get your feedback on our courses up there. And I'll also mention that we're looking for authors because we've got a lot of ideas on courses that we think would be great. So feel free to propose a course to me on anything that you don't see up at Like Now because we'll pay you to do it. We're looking for some good stuff. Okay, so any questions?
Once again, John, thank you very much for coming on board and telling us some stuff that most of us probably didn't know, to be perfectly honest with you. I mean, I've done .NET now. I mean, I remember the pre-alphas before version 1, which I guess you probably do as well.
Yeah.
And every time I see one of your presentations, I learn something that I didn't even know.
Good.
What can I say? It's always fantastic stuff, and it's always a really good technical deep dive. For the record, if it had been anybody else, I'd have probably pulled the plug by now.
Yeah, I always think an hour and a half, I got to do it, and I always go too long. So I appreciate everybody sticking around because I wanted you to get the value.
Well, Brian's already gone. He had to go to work.
Yeah.
Although, I've got to admit, those Aussies are crazy. I mean, he starts work at like 4 o'clock in the morning.
Yeah.
It's the, go on, fill your boots, do whatever you like, But yeah, really, really good technical deep dive there, John. And I don't need to say I hope you'll come back again because I know for a fact you will.
Oh, I will. Yeah, we've been working on a lot of new stuff. We're really getting into Roslyn quite a bit, or at least I am. A lot of us at Winterlake have been playing with it, so maybe I'll do a session on how to write these Roslyn analyzers and code fixes. Because,
well, why not? Why not?
There's some excellent things.
It's a pity you weren't over here in the UK, because at the end of this month, I'm actually presenting myself at Developer up in Scotland, here in the UK, and I'm presenting on, you know this new microservice architecture that everybody's going on about, using Katana and Owen?
Oh yeah.
Yeah. I'm doing a presentation on that, and basically why Orwin and Katana is going to rule the landscape with it.
Oh yeah.
You know, it should be a very nice one.
Microsoft's bet the farm on that. Okay.
But while I mean, I'm not too fussed at us overrun, and like I said, Brian had to go. But while I've got your attention,
sure.
Really, it's nothing to do with the presentation you've just done, but I'd like, as somebody who's deep in there, deep in the trenches, deeper in the trenches than most of us are, I'm just interested in what your take on Microsoft's move to open source all of the .NET stuff is.
Oh my God.
Yeah, you could have knocked me over with a feather when I was watching Connect at the other day.
I know. We had the MVP summit the week before, and I have never seen so many people walking around just gobsmacked at what was happening, because they gave us all the announcements the week early. And let me tell you, this is not your father's Microsoft. And I realize Satya Nadella is trying to build a new culture. To see that culture going down to the lowest levels in Microsoft, I've been working with Microsoft since 1995, and so I got to live through the scream and match meeting times and everything else. And more people were excited about Microsoft than I have seen in pretty much the whole time I've been working.
Absolutely.
These announcements and their approach, the humble approach that they're taking, I think is going to help everybody on this call immensely. I think it's going to make Microsoft much more relevant in the world. It was, like I said, this, it's the most excited I've seen people since I started working with Microsoft in '95. I mean, it's amazing stuff.
For sure. It's I mean, I was actually sat there. When you take a double take. Yeah. And I was sat there watching it. It was just like in slow motion. It's like, what did he just say?
Yeah. Now, hey, JB's got a question here. He wants a link to the presentation you're going to be doing and the developer link. So make sure to answer him.
JB, yes. Off the top of my head, look for dunddd.co.uk or dddscott.co.uk. Actually, yeah, you've got control of your browser there, John. There you go, DunDDD. That's the one. And if you click on sessions there. Just on the...
Oh, there we go.
Yep, and then if you scroll down through that, you will see my session is listed in there somewhere.
There it is. Here's Peter Shaw. Microservices architecture. Exactly. Yeah. Yeah, this is, this is a great time to be a Microsoft developer. It's, it's wow. And we've got more stuff coming. That's the thing that's, this just wasn't a one-time announcements.
Scary, isn't it? I mean, the one question I've been getting asked again and again and again, and this is the one theme I've seen reoccurring in the discussions and everything that's been piled into LIDNUG as well, is with Microsoft open sourcing all of this lot, how the hell are they going to continue to make money?
Well, I think you got to think of. I think they're going to make a lot of money. I think Visual Studio will always be the best environment for developing these things. I think the big thing is services and Office 365 and getting people up on Azure. It was kind of funny. We go in our consulting business, we go talk to a lot of companies, and a lot of companies that were spending a lot of money on Amazon are now looking very seriously at spending even more money.
Amazon. Yeah, exactly.
Yeah, going to Azure. So there's, I think that there's all sorts of things like that can make Microsoft a good bit of money. Now, is it going to be the same hugely profitable? That's what they have to figure out. But I think that they're going to make it so compelling and that provide that end-to-end service so that they if they win in Azure, they're making money hand over fist, and,
Yeah, yeah.
and they're already doing extremely well with look at Office 365. We moved to at Wintellect. I moved the company to it. Gosh, before it was called Office 365, Microsoft Online Services, and I cut my company's IT bills by 70% in a day.
Wow.
So
I've heard some impressive stories, but that's
oh yeah.
good.
Yeah,
That's a big chunk of change, that.
And it's been, the amount of management overhead that goes into me, because I'm the IT guy, and I guess I get to be the CIO of Wintellect. The amount of management time that goes into this is a whopping average of 5 minutes a week. So, here I've got a company that, 30 employees, probably another 20, 30 contractors, and I'm only spending 5 minutes a week on Exchange and SharePoint and all that stuff. And it's costing me essentially nothing, So I think Microsoft's going to make a lot there. I think there's very aggressive plans with getting Windows everywhere. I think we've got Internet of Things, which, we're just starting to scratch the surface on that. I think that's going to really open up tremendous opportunities. And, I think, all this back-end stuff is going to be all run on Azure because it's just going to be so simple to do.
Well, another thing that strikes me as well, I was at an SQL Relay event just a little while ago, and we had one of their data guys up going on about the advancements that are coming out on the SQL Server platform. And in almost one sentence, he completely redefined the landscape. And that one sentence was, in the future, Microsoft doesn't care about big data. It only cares about all data.
Yeah.
And it was just like, you've just turned the entire landscape on your head with that saying,
Yeah. This Internet of Things stuff is going to be amazing. I had a talk with Rob Tiffany, who's one of their guys that's kind of leading the business challenge of Internet of Things. And, nobody's done big data yet. And
not properly, no.
And when we start seeing truly big data, because the only companies that are doing big data are Google and Facebook and Amazon, and that's about it. None of my customers are doing big data, right?
Yeah, but you've got all these others that believe they are just because they're using Hadoop and sort of stuff like that.
Exactly.
To do massive amounts of MapReduce, But it's really not. It's just mass volume processing. If you want to give it a label.
Yeah, and I think if you take the data that everybody that's listening here that you're dealing with today and multiply it by about 1 million. That's how big Internet of Things is going to take things.
Oh, for sure.
So it's going to be a wild ride, my friend.
Indeed. Right. Well, I'm going to stop the video there because the video's just hit 2 hours. So thank you once again.
Thank you very much. And if anybody has any questions, want to follow up, John at Wintellect.com, at John Wintellect, and grab your free 2 weeks at Wintellect Now.